Here we have to solve another one question from Jest 2018. Okay, let me take. So this is the question. An apparatus is made from two concentric conducting cylinders of radii A and B respectively. A is less than B. Okay, the inner cylinder is grounded and the outer cylinder is at a positive potential V. The space between the cylinder has a uniform magnetic field H directed along the axis of the cylinders. Electrons have the inner cylinder with zero speed and travel towards the outer cylinder. What is the threshold value of voltage below which the electron can't reach the outer cylinder? Okay, and I have already drawn the figure. See, this is our concentric conducting cylinders, which inner cylinder of radius A, outer cylinder of radius B, and a uniform magnetic field is directed along the axis of the cylinder. That is here uniform uniform magnetic field here. Okay, along the axis, that is along this. Okay, then here. So after this, an electron leaves the inner cylinder with zero speed, and that is starting from U is equal to 0, electron is moving towards the outer cylinder, so that we have to find the threshold value of voltage P. So electron can't reach the outer cylinder. That means it can go up to B, outer radius B. So let's solve how it's going. This is the threshold voltage. We have to calculate threshold voltage. Okay. This is the mixture of EMT plus classical mechanics. This is a little bit lengthy question. Okay, let's start solution. As we know, Lorentz force. Lorentz force. It involves the velocity vector of the particle and the speed of the particle. That is, force is equal to E by C V cross P vector. Okay, this is the Lorentz force. And as you know, dl by dt is equal to our torque, and torque is equal to r cross f, and here r cross f are perpendicular to each other, so r f we can write. Okay, and L is the angular momentum. Angular momentum is equal to m r square omega, and omega is equal to theta dot, so we can take as theta dot. So okay, then m r square theta dot divided by dt is equal to rf. Put the value of f, and p and also see that magnetic field p and f, that is force, are perpendicular to each other. So p is perpendicular to b, so we can write f as E by C Vb, and here b is magnetic field, so we can write instead of b h. Okay, and p is the we have velocity. Velocity we can write dr by dt. So d of m r square theta dot divided by dt is equal to r e by c dv by dt into h. So let's move to this. Okay. Cancel and sorry, v is dr by dt, this is r. So integrate both the side. M r square theta dot is equal to e by c h integration of r dr, and here the limit will be from a to r. Let us suppose r, this is our Gaussian surface, a to r. Let's go to the next slide. So r square theta dot is equal to e by 2c m h into r square minus s square. Okay, this is equation 1. Okay, let's do energy conservation. By energy conservation, change in kinetic energy is equal to change in potential energy. So our change in kinetic energy, that means electron is coming from initial velocity u is equal to 0 with some velocity u is equal to 0. So as it is moving, so it will have kinetic energy. That kinetic energy is converted to the potential energy, so that electron can go outside the cylinder. Okay, half m v square is equal to ev. V is the threshold voltage. Okay, but we have to write it in polar form. Half m r dot square plus r square theta dot square is equal to e v threshold. Here r dot will be 0 as it will reach at p and radius is constant. That is p. So this term vanishes. So half m r square theta dot square is equal to e v threshold. So v threshold will be m r square theta dot square divided by 2e. This is our threshold voltage. Okay, and we have to take theta from here. Theta dot is equal to e h divided by 2 r square cm r square minus a square. Put it in equation 2. That is v threshold will be m r square theta dot divided by 2e into theta square will be e square h square r square minus a square whole square divided by 4 at work 4 c square m square. Okay, r square and square get cancelled, e get cancelled, so our final answer will be e b square minus a square whole square into h square divided by 8 m square c square and r square. This is the B threshold. But electron should not reach the outer, should reach at outer but can't go outside. So R will be also be, sorry, put R equal to B. So our final answer will be B threshold will be E h square p square minus a square whole square divided by 8 m square c square, sorry, m get cancelled, so that will be only m c square b square. This is the threshold value of voltage so that electron can't reach outside cylinder. That's the answer. Okay, thank you. Please do subscribe, like and share with your friends.